There we go. Recording started. Okay, so welcome to the HASP 2026 Q&A virtual meeting. Um, Looks like we've got a lot of interest, which is fantastic. Um, but I'm just gonna, first off, I'm gonna take off with just a little recap of what HASP is, and then we'll get into the call for proposal and the application process. Share going, boom. Okay, so this is HASP. It has Doug Range and Aaron Ryan. I did not add Sabrina. I need to add Sabrina to this as well, just so she's on there. Sabrina's our resident electrical help. She works in the electronics shop in the physics department for the College of Sciences. HASP is a partnership between the NASA Science Mission Directorate Astrophysics Division, NASA's Balloon Program Office, the CSBF, which is Columbia Scientific Balloon Facility, and Louisiana Space Grant Consortium. The partnership basically works with BPO. CSBF provides the balloons, the launch opportunity, the staffing to make the launch, such. Space Grant provides a little bit of support funds. Originally, they provided all of the support funds, but in 2020, NASA Science Mission Directorate awarded us a contract to basically they fund HASP each year fully, and any support we need from elsewhere we can get. But it's mostly a full NASA Science Mission Directorate experiment now. It was developed way back in 2005 as a way to train the next level of, or the next generation of aerospace sciences, engineers. Students get hands-on experience on how to develop and run a science program, which is what's vital when you move to the next step for grad school, PhD, stuff like that. We provide a regular flight opportunity for what amounts to students across the globe. We've had as you'll see, we've had teams, a couple international teams fly quite regularly on HASP. Basically, this is what HASP looks like. It's designed to support up to 16 smalls and 8 larges. The 8 larges may or may not be an issue. We absolutely can support 4, and up to 4 more is a little bit of a work in progress. HASP provides a serial downlink, serial uplink for us to send commands to. There's a network downlink which pulls, which all the student data all the student data travels through, and we can do commanding, manage flight operations. Cameras come down that network link. Students do not have access to the network link yet, but your data does come down that network. We provide the ability for discrete commanding and analog downlinks. And then there are also, on the last flight, 3 flight cameras. They're mounted there, and there in the picture. We'll talk about the cameras in a little bit, but basically this is HASP in the 2025 launch window. This was a few weeks ago. In the lab, and this is an older version of HASP. This is the HASP-1 frame from a couple of years ago hanging on the launch vehicle. But you can see the basic layout where the student payloads go. The second 8 will go on the bottom ring down here. The 4 larges go up here, and then 4 additionals can go on the bottom, but that's going to take some extra work. And this is HASP hanging. The smalls are on the edges, larges on top. And this is all the CSBF communication equipment that's required to send their serial commanding, to track the payloads, to send the balloon chute stuff. Typical, this was a HASP launch a couple of years ago. As you can see, HASP was hanging on the launch vehicle way over here. This flight train's about 600 feet in length. The balloon is an 11 million cubic inch balloon, cubic foot balloon, sorry. Holds a lot. It's larger than a small college football stadium. This is and it's designed to take our weight up to about 36 kilometers, 120,000 feet. And for this year's launch, I think with our max load, we were able to go to 126 without ballast and 122 with ballast. So that's pretty much where we float. We takes about 2 hours. If you look in the bottom right, this is a typical flight profile for HASP. It's an old flight profile, but a typical one. Launch takes about 2 hours to get from ground level to float. And then you can float for, we average about 13 hours. Typical, our range, I think, is like, well, we'll see the next slide, but 13 is the average. We've had some as long as 31, 27, and some short ones due to weather or other issues. This is a typical flight pattern on the bottom left. You launch out of Fort Sumner, New Mexico here. Typically, the climb out tends to go east a little bit. And then once you get up to altitude, it drifts, it starts going west, but it's not always due west. We've had some go pretty far southwest. We've had some go pretty far northwest as well. So, but west is the prevailing flight pattern. We typically launch before the winds turn around. So at the end of September, the upper level winds actually change directions and start flowing east. We launch before that so we can get out of New Mexico before some of the bigger payloads that require large amount of nighttime sky to fly. Those typically launch when turnaround happens, so they maximize their nighttime hours. This is typical characteristics of all 19 missions that HASP has flown so far. We've had over 1,900 students participate from 57 unique institutions from 27 states and U.S. states and territories. Belgium, Canada, England, and Peru teams have also flown on HASP. So we're spread out. Typical flights, as you can see, we've had a total of about 250 hours if you sum up all our float times. But yeah, this year we accepted 12, flown 12, and all 12 had some successful data. So that's a great chance. We try to keep that as high as possible. This just basically shows the spread of HASP teams as of September 2024 for this one. This is all unique institutions across the country. We'd like to fill in these white spots at some point if we can. And then on the right side were the jurisdictions for just HASP 2025. And I'm going to blow through these slides pretty quick. In 2020, we got a grant to build the next version of HASP. HASP was getting old. It was 16. It had been flown for 16 plus years using equipment and computer parts from the 1990s. It was time to replace. So in 2023, we began sketching out and started planning for building HASP 2. In August 2024, we actually flew the engineering flight for HASP 2 with flight computers and some prototype hardware, stuff like that. Worked really well. We were able to take that knowledge. And this year we actually was the inaugural year of the new HASP platform, which flew on all new equipment. So brand new electronics, brand new flight computers, brand new frame. Aaron designed and built the frame. So yeah, here's kind of the redesign. I'm going to blow, we don't really need to go into much detail on this, but basically this would be the layout if we had 16 smalls and 4 larges in this one. The inside here has the batteries, flight computers, electronics. These are just the upgrades. Of note is we've started using the Starlink system as a network downlink. So this year we had our 3 flight computers, 3 flight cameras, and the whole HASP data downlink system coming through Starlink. So we were actually able to remotely remotely log in to the flight computers from the ground via SSH which is fantastic if we need to do some adjustments, things like that. We did run into a little bit of an issue with some choppiness of the Starlink signal. It didn't affect our data, but it did affect the flight cameras. So if we figure out what's going on with the flight cameras and the Starlink system and why the Starlink was a bit choppy, we'll stay with that. If not, we may switch the cameras back to the unidirectional EVTM, which is a stream down. And as usual, we'll keep the serial interfaces as our redundancy. So that's our backup system. We can still send commands up through the serial interface and telemeter some data down. And that's just a quick run through of HASP history. We'll get to questions in a second. I just wanted to make a little run through, but basically that's the history of HASP. Next, we have Aaron. Did you want to add anything about that? Sorry, I'm kind of blowing fast. Nope. Okay. Next, we'll go on to the HASP site. I am in the process of migrating web servers. So the original address, lostspace.lsu.edu/HASP still works. It just forwards to the new server. This address will eventually be lostspace.lsu.edu again, but it just hasn't migrated. But here's the new HASP website. Pretty simple. It's pretty bare bones too. We have a call for proposal, news of this year's launch, etc. Menu structure. Just shows flight details. You can actually see our environmental displays, stuff like that teams get in real time while we're flying, which is great. You can do the map tracking, get the video feed links, and the control interface, which we'll go into later. And then big thing is participant info. In participant info, this has the links to the call for proposal, the submission form for the Q&A, and the notice of intent. I'll add the submission form for the application, but that's also in the CFP. Has a link to the proposal template that all teams must follow. And then a couple older examples, a link to the student interface. And there is one change here that is not in the student interface manual that I'd like teams to notice. In the student interface manual, we talk about small payloads having a 1200 baud system for their communications link on the serial, or on the serial interface for the payloads. With Starlink, we have ample bandwidth to pull data down. So we're actually going to move that up and allow small payloads to have up to the 48, the same as the larges. Probably just set them all at 48, but that is configurable. But that just gives smaller teams a little bit more access to the little bit more data to, the data set. Go back to participant info. Like I said, all the links are here. On the document center, this also has all the links. This is where you would get all of the deliverables that we require over the course of the year. They're all just stored here. These will get updated. Probably at some point going to make a science mission template for their report just to make it more uniform and make sure that everything we need in the science reports are covered. And that's basically the general runaround for the website. You can find the student interface manual on the website. Like I said, there was that one change for the baud rates. And that covers the website. Does anyone have any questions on what I've gone over so far? We'll start tearing into the call for proposal and the cover sheet and proposal template in a second. Does anyone have any questions? Woo.
Yes.
Yes.
The payload that we're thinking of working on and could be sensitive to the dynamics of the balloon. Do you have any past data about what you call rates of rotation, acceleration, velocity, temperature, pressure, all that sort of stuff that we could grab?
So temperature, pressure, all that stuff. Yes. I mean, there's ample data for temperature and pressure and stuff like that. You can go back to the previous flights and look at our housekeeping stuff, and that has temperature, pressures. But generally, temperatures can range from probably if you're in direct sunlight at peak daylight times, you're looking at maybe positive 50 right in the direct beam of the sun. Maybe a little bit less, but HASP slowly rotates, so you're not always sitting in the sun. But you can get that pretty high. When the sun goes down, HASP gets really, really cold. So on really long flights where we actually drift into the night cycle, I mean, there's no the only thing keeping you alive is basically your electronics, right? Or keeping you fighting against the cold is your electronics. And HASP will get pretty cold. I've seen, I'm trying to remember, minus 30s, minus 40s on the solar shields.
Oh, okay.
Well, the real
But
answer is temperature is dominated by the radiative heat transfer
right.
and the actual power you're producing in your payloads, right? There's not really a heat sink for you to equalize with. So if you're in shadow or it's during the night, you'll probably be, if it's down looking, you're gonna equalize with ground temperature. Up looking, you'll try and equalize with the microwave background. When you're in direct sunlight, you will try and equalize with the sun, but hopefully you're reflecting most of that light. So,
Yeah. Which is one of the reasons why we recommend painting your payload like white with a reflective paint, or we have a polished aluminum interior so the heat reflects inside of the payload, and then a white skin on the outside to reflect solar away.
And then flight dynamics, honestly, the best thing to do is if you go, let me just drop so all of those, Doug mentioned the streaming cameras. All right. So the videos from previous year flights, from what we have, are available on the Louisiana Space Grant webpage, and there are playlists for various flights, and that's where you can get, uh, we don't have any archives of like accelerometer or gyroscope data. The acceleration up and down, like vertical acceleration, is relatively small. Not this is a much stabler platform compared to like a sounding balloon. And then the rotation rate is somewhere in the neighborhood of, I would say, about 15 minutes per rotation. So,
Okay.
but with a
And
lot
it goes
yeah,
back and forth.
Yeah.
I mean, you're not constantly rotating in one direction. You actually kind of bounce around a little bit.
Now we do not fly a rotator or pointing system, so it will freely rotate. So that is, depending on your goals, that may be a concern. So
Got it. Thanks so much.
Yeah, we've talked about putting accelerometers, and we've had teams do it. The data coming out of it is, we don't have any perfect data coming out. It'd be nice to add one. We just haven't. The one we were looking at was a little beefy, a little more expensive than we wanted.
Yeah, I guess the other caveat I will add to that is, so while float and flight are relatively low acceleration, the design criteria for termination is 8G vertical, and I think 4G horizontal. One of the linked documents in the CFP is the gondola design criteria. So that's based on the actual termination shock when the parachute catches. So that's, and then impact is obviously also a potential high acceleration event.
Fantastic. Thank you.
Okay. All right, we'll move to the call for proposal and then the proposal template, and then we'll open up for questions. So the call for proposal, I'm assuming everyone in the meeting has, since you joined up. Basically, it's just general introduction of HASP, gives some general numbers, has a bunch of links. All these links, like HASP participant info, right now, that link won't go directly to the participant info page. It'll go to the main HASP page, and then you've got to trace it. That's just the way the forward is working. Notice that the notice of intent, if you intend to, or at least are thinking of providing an application, you need to provide a notice of intent. That is due by the end of day, October 6th, 2025. And then applications will be due by the end of day, November 3rd, 2025. That gives us about a month to get our reviewers reviewing applications, stuff like that. We'll try to make the announcement of payload seats very early December. We shoot for like the end of the first week. So notifications will occur then, and then we'll have a kickoff meeting in early January, basically starting the process and introducing all the teams, stuff like that. Aaron's gone through the application. We've done through the application stuff. Aaron's made a bunch of changes. I will say things like preliminary drawings. We still want design drawings. They need to have dimensions. We understand they're preliminary, that they can change. These aren't locking you into a design, but when we do the application process, we want design drawings with dimensions. And we'll go over that in the cover sheet. I'm just kind of scrolling down, hitting a couple big points. Basically, this goes through your submission stuff, financial support. Currently, HASP does not provide financial support to teams. Teams are responsible for going out and getting their own financial support. You just can't pay for travel, stuff like that. And in the future, that's a hope, but right now it's just not possible. And yeah, it's just not possible. Private company support. You can get private company support. They can give you money. They can support things, stuff like that. We're not advertising for private companies. You can put a sticker on, that's great, but they cannot use that data as a, like a cell phone company putting a cell phone on the flight and saying, see, our cell phones work up at 120,000 feet in space, blah, blah, blah. That's not allowed. We can't do that. If they give you money for work and you want to put a sticker on their stuff on the side of your payload, that's okay. But they can't use this data as proof of, proof of experience, stuff like that. We've gone over this Q&As today. We'll have another Q&A on October 17th. That additional questions, that'll also any questions, specific questions you've had while you're building your proposal. We'll add that there. Proposals will due on the 3rd, as I said. Submission link is right here. I can add the submission link here onto the website, but it's buried in the NOI. The rest, again, is just some direct information as to interfaces, what HASP is, hazard tables. So hazards. These hazards have been set by both HASP admin and NASA safety. So cryogenic materials is banned just because dealing with NASA safety and all the clearances that are required is just a nightmare. So there are some that say see appendix, which is a bunch of forms and information we have to provide, but others are just outright banned because of the problems that they incur. These include rechargeable batteries. Let's see, special requests. So the special requests.
Doug,
yes.
Hold up.
Yep.
So if you are flying one of the allowed hazard, there is a required supplemental table of additional information. At time of application, you you can include preliminary, but at one of the deliverables, the pre-PSIP in April, that will have to be finalized. So we want you to fill that out as complete as possible at this time, but it can be preliminary. But it will eventually need to be finalized.
Last thing I really want to talk about for the CFP is special requests, and we'll go over it again in proposals. You have a special request where you need to operate outside of the confines of the HASP, the footprint, the weight, some kind of power issue, stuff like that. You need to make a special request. That is a request waiver that needs to be documented, why you need it, drawings, examples, spreadsheets, power budget, stuff like that, the impact it'll cause against, the impact it'll have on your payload if it's not allowed, stuff like that. We have a footprint for a reason. So if you need to be outside of it, we need to understand why, or perhaps HASP is not the payload's vehicle for you. Anticipated schedule, we've done the beginnings, we have the Q&As, the notice of intent is October 7th. The next Q&A is on the 17th. Applications due on the 3rd. Announcements due December 5th, early December. January 16th, we'll have the kickoff meeting. And then from February through November, we'll have monthly telecons where we'll get together, discuss what's going on, provide information about what we need to provide for you for that month, and then answer questions or any issues you guys have popped up with. There will be a status report due the week before the monthly telecon. So we'll go over your status report and we'll have comments or questions for you guys during the monthly meetings. The end of March is the preliminary PSIP. That is the document that'll need to have finalized hazards. And as you get awarded, we'll go through that more. But basically, that's the one that NASA safety needs to know what hazards you are using if your team is using one, because it takes them a few weeks or months to review. In April, we'll need a security document. That is, we need to get clearances for people to go on base, on a NASA facility base, and that takes up to 2 months. So we'll need by the end of April for our trip to Palestine in July. At the end of June, we'll have the final PSIP, which is basically payload integration plan. This basically tells us everything we need to know about your payload. At the end of June, we'll also have the flight security document. That is for any teams going to flight operations in New Mexico. The FLOP, which is our flight operations plan, that will be due right before integration. The FLOP basically tells us how to operate your payload. Commands, power draw, stuff like that. How many, what your data should look like, stuff like that. Integration at CSBF will be in July. We'll go through 2 rounds of thermal vac testing for student teams. So the entire HASP payload will get loaded into a very large thermal vac chamber, and we'll do some environmental tests to make sure your payloads work at extreme colds, extreme heat, and at float altitudes. Flight preparations will be at the end of August. We'll shoot for our target ready date. These are very preliminary. Usually our target ready date is right before Labor Day. And so we try to fly as close to Labor Day as possible. And then it takes a couple days after flight for recovery to happen. The payload gets transported back to the facility. Then we'll package everything up, ship it back, and then you should hopefully get your payloads around end of September very early October, hopefully. And then final science reports are due in December. Let's hit the cover sheet because I want to shoot for a good amount of time for questions. So basically, I'm on the cover sheet and proposal template. Each team submitting a proposal will have to fill out this. This is very general, just payload abstract, title, institution. Select whether you're going to be a large or small class, and then general contact information for both the student lead and the faculty advisor. Next page, the hazard materials list. If you intend to have one of these hazards, you need to check it, let us know you're going to have a hazard, and then both the faculty advisor and the student team lead need to sign it. If you're not, just put X's and move on and don't worry about it. So payload description, it's pretty obvious. We just want a general payload description of what your payload is, the why, what, how of your payloads, the background. We need a technical and science background of why you're doing this, what you intend to do. Mission statement can be really, really quick. This is what we intend to do. So these sections are all very general. The instructions should simply explain what's going on, your mission objectives, your payload systems. For your application, we want a high-level description of your payloads. If you want to go into detail, that's fantastic. If you have those details already, great. But we want a general high-level explanation of what your payload is. We want to know about your major system components. We don't need to know about this resistor or this capacitor or stuff like that, but we want to know this is our data collection system. This is our sensor package. This is, our mechanical structure, stuff like that. Mechanical structure and design is obvious when where is it? Yeah, the tables are down further. Okay. So basically this is just a text write-up with pictures if you want, which would be nice, of your whole payload for section 1. Full write-up, electrical design, thermal control plan. We do not provide thermal controls for you, so teams need to discuss how they intend to handle the temperature extremes that they could experience. Paint our payload white. That hopefully reflects, solar away, and hopefully that keeps us cooler during the day. A little bit of insulation on the inside if we need. That'll try to keep the heat generated by our electronics and stuff like that. You just need to plan for your thermal design. Section 2, we need just the discussion on your team structure, the roles of your team members, organizational charts, stuff like that. We would like, is it in this section? I can't remember now. Yeah, we would like your timelines and milestones. It doesn't have to be a massive Gantt chart that shows every step of your payload, but we want to make sure that your team is budgeting your time appropriately and you have a pretty good idea on what your schedule will be. Anticipation, integration. This section, we just want to know what your plans are, general plans. We'll get more detail with this section in the PSIPs and the FLOP. So this doesn't need to be very detailed. It's just, we intend to have a team come to integration. We are considering having a team come to flight. At flight, it would be 4 to 5 students, something like that. We don't need a whole lot of detail. Payload specifications and your interface specifications. Weight budget. No one is a final weight budget right now. We understand. We want just a general idea of what your weights are going to be. Remember, smalls have both payload sets have a weight limit, so you want to be sure you're planning accordingly for that. Most of this is going to be estimates right now, but we just want a general idea of your payload weights, your payload power budget, etc. We want downlink data. We do not require teams to downlink flight data for monitoring. We highly recommend that teams do this. If you don't have data coming down, you have no idea if you are flying a brick or not. So we want discussions on your downlink, what you intend for your downlink systems. You don't have to do serial commanding if you don't want to, uplink commanding. We advise that you have some commands. It's nice to turn off this sensor, turn on that sensor, recalibrate this sensor, configure this, send a command so that send a status command so that your payload's operating properly, something like that. We recommend both a downlink and commanding feature on your payload. Analog downlinks, we now have the capability of having some analog downlinks that are in the data stream that display on the website. So those would be simple things like we've put a temperature sensor on there, or it's just a 0 to 5 volt display. So you could have, if this is live, it's open, something like that. But the analog downlinks just help with some housekeeping. If you so choose, it's not required. Same for discretes. We'll use discrete commanding. All teams get 2 discretes, on, off. We provide an additional discrete to payload teams if they want to use it, which could be open shutter or some kind of vital command. You don't have to use it. You could use normal commands to do the same thing, but this discrete gives you a separate path for a vital command if you need. Payload orientation, we'd like you to tell us where you would like to be seated. So if you look at the design of HASP and the call for proposal, you could choose your payload seats accordingly.
Correction, only if you need a specific seat, right? Like if you need a downlooking capability, or if you need a specific orientation. So
that's fine. Yeah, I use those to space out. So if you need a specific spot, Aaron's right, tell me. That way I can make sure that I slot you there and put other payloads that don't need a specific spot around. Special requests. Again, this would be your waivers. If you need them, we need details, reasons why, impact to science, stuff like that. Not just because it would be cool to have more data. That's not a valid reason for a waiver. So be careful with that. Preliminary drawings, this is my point again. Mechanical drawings, we need dimensions, we need notifications, stuff like, we need to understand the size of your payload. Putting it on a network, on a napkin or something like that and taking a picture doesn't really help us. We'd like it in a mechanical design sheet. If it's just sketched out, we need dimensions on just simple sketches, but we need good preliminary drawings. Section 5 is just references. That's great. Then we get to the appendices. Appendices are just anything extra you want to include in your application. Appendices A is preliminary drawings, stuff like that. That would be wonderful. Appendix B are the hazard documents. So this, for the application, just if you're thinking of having an RF system and you're not sure what, you don't have to specify anything yet. Let us know you're intending to use this and fill out as much as you can. In the PSIPs in April, these are going to have to be finalized. But for the application, just provide as much as you can. And they are subject to change. We understand that. We just like to have NASA safety prepared. Most of these are pretty simple. The RF is pretty simple. The high voltage is pretty simple. Where is it? The battery one is pretty simple. The pressure systems, if you intend to have a pressure vessel, it is a lot of work. So there's a lot of requirements that are needed. They're going to want to see drawings. They're going to want to see proof. They're going to want all of this information. So pressure vessels, while we allow them, take a lot of extra work for the teams. And I can guarantee NASA Safety is going to ask a lot of questions about it. So that's the CFP. I'm gonna ask Aaron or Sabrina if they have anything they want to add, and then I think I'll just open it up for questions.
I've got nothing to add at this time, Doug.
Okay.
Me neither.
Okay. Awesome. All right. Well, then with that, I am going to open it up for questions. Please feel free to ask. There's a good time. Now's the best time to ask about your applications if you need it. So fire away. Colby.
Yeah, I know. I think Aaron mentioned earlier about if you require either a down looking or up looking location in on the platform. Is that part of the application where we get to specify, hey, like we'd prefer this, and we say like why, for example?
Yes. That is section 3.7.
Okay.
Payload location and orientation request. If we want an upward looking camera, we're applying for a small seat, so we want to be on 1 through 8 of the small payload seats.
Right.
If we request being inside the camera range because we have shutters that want to be open, so the camera we want to be visible to the camera at all times or something like that.
Right. Okay. And also, is HASP controlled at all through GNC or Guidance Navigation Control, or is it basically directed by the winds, like when it's
it is by the winds?
36?
There's no control.
Okay. Yeah, our project is going to be looking towards solar or types of radiation, but
yeah,
facing the sun will help.
It travels with the high altitude winds.
Right. Okay. All right. Sounds good. That's all the questions I have.
Yeah. So for example, typically if you need to be looking at the sun, that means your payload needs some sort of tracking azimuth and elevation system of your own. So.
All right. Thank you.
Yep.
Mm-hmm.
Ariana.
Hi, I would have a few questions. So first of all, I was wondering if there's payloads that are going to have like radio emissions or other things that could affect our payload. Would we be able to be like to know of this or like know what other payloads are going on the launch?
Will you be able to know? We can provide that. Typically, we haven't in the past, just because no one's ever asked for it. Okay. But yes, once we get all the hazard lists done, we can certainly make sure that no one is. I mean, the goal is to make sure no one's overlapping, stuff like that, interfering with each other. Some of the RF stuff, there are automatic keep outs, like certain ranges are CSBF equipment only. But yes, we can certainly, and in the RF safety plan, which CSBF, NASA Safety puts out, that's all documented, but that doesn't happen until much later in the season. But yeah, we can certainly let you guys, publish it once we pick. As soon as we get accurate information, we can actually provide it to all the approved teams. Yes.
Yeah, awesome. Okay. And then also I was wondering if you already knew of any radio emissions that are going to be on the balloon already, and and what frequency bands they would be. And if not, that's okay.
Not missions yet, but there is the telemetry, the CSBF telemetry, and we could probably pull last year's RF docket and provide that if needed.
Okay, thank you so much. And then also, I was wondering if you guys have any advice in terms of grants or student opportunities that other people have done in the past. I know you guys don't provide funding, but if you knew of any opportunities that have been successful for other teams doing this.
Space grants.
Space grants?
Every state has a space grant office.
Okay.
And a lot of them provide funding. So I would recommend, look for what state are you?
Philadelphia or Pennsylvania.
Okay, so Pennsylvania. Yeah, Pennsylvania's space grant is a pretty active space grant. So yeah, I would try to get in contact with the space grant office, and and see how they do funding. In Louisiana, we actually have a program for providing funds for advanced flight opportunities and stuff like that. RockSat, Rock On, HASP. Well, not Rock On, RockSat and HASP, etc. So it's possible that Pennsylvania has funds for student space flight opportunities.
Okay.
In addition, is there anybody from College of the Canyons on the call right now? Okay. The reason I was gonna ask them is, so that's a community college team out of California, and I know they do a lot of private fundraising to fund their team. So if you send an email to HASP about that, we can probably ask them if they have any, sort of pointers or suggestions for private fundraising.
Yeah, or we could put you directly in touch with Teresa too.
Yep.
Oh, awesome. Okay. And then also sorry.
Hang on before you go. One additional caveat about RF. So we do the flight paths typically are in the region of White Sands missile base. So that is one. There's some testing. That's also like sometimes they do GPS jamming. That's not anything we can control, and that is also inside. If anyone is familiar with ham radio, there's a big box in Texas and New Mexico with some extra restrictions on the 33 centimeter band. So we typically are in that box the entire flight. Again, and that's all due to White Sands missile base. So.
Okay.
Yeah, they like to jam GPS occasionally. Just for fun. Not really, but yeah. Okay, you had one more, Ariana? Or some more, Ariana?
And then where do we get the recording of this call?
I'll provide it after.
Okay, awesome. Thank you so much.
Bookwan.
Hi, Doc. I have a similar question on RF side of that. I will add another Iridium tracker running at 1.6 gigahertz Iridium satellites to get GPS and also the location of the payload so that our ground station can steer. We worked on a precise steering from the ground station over the past year, and with the lessons learned from a 2023 campaign, they're pointing the ground station toward the payload is very critical, and I think we achieved very accurate steering. So I was wondering, the NAL Iridium tracker that we normally do for the balloon, high altitude balloon, EVP, for example, would it be causing a lot of issues to go through the hazard clearance?
I would put that in your application quick in the RF section for this cycle. Put as much information as you can. We have flown that tracker before. I believe, did you guys fly it a couple years ago? I know Randy flew it at least once.
Yeah, same model, NAL L9602
yeah.
from Montana, same model.
Yeah, that shouldn't be a problem, but just put all that information in. I believe we've had those clearances before, and it's not a big deal.
Okay.
Yeah, there's a couple of Iridium communications ports for CSBF stuff as well. We'll just have to make sure that there's no one stepping on each other.
Okay, and then same as 2023, we're going to be using 435 the VHF band to transmit our videos to that ground station. We're going to be steering through Iridium tracker. So I guess that clearance would be valid again in 2026.
No. Everything is fresh. You can't just assume because it was cleared last time. That does not give you clearance on the new flight, right?
But from the last time, we know who to contact and things like that. So that's a good starting point. Yeah. Certainly we'll go through that.
That's a good starting point, but it has to be approved every single year. So I still need you to put it in the RF hazard stuff.
Sure, absolutely. Thank you.
Right. And also, just to be clear, just because putting RF hazards in the table does not clear you with any FCC or other regulations, right? This is entirely for safety of payload and safety of the other systems, right? All of the overarching FCC regulations are still applicable.
That's correct. Okay,
Yeah.
well, no issues because we are so low in transmit power. That was the basically key to get approval in 2023. And
Right.
we do have a ham radio licensee operating that 435 megahertz band. And then the Iridium doesn't require any license because it's already a commercial product and so. All
Yep.
right, I think it's good. Thank you.
Absolutely. Is that it, Wukwan? You're good?
That's it. Thank you very much.
All right, absolutely. Okay, Larry.
Hi, and how are you?
I am just fine. How are you guys?
Good. I participated back in 2016, 2017 in HASP with the University of Bridgeport. And I have a question on the new system since you're using Starlink for telemetry and stuff. You, in the past, you had we had typed a command, and it went through the web to a site, and then someone else had to manually enter the command to send it uplink. I'm
Correct.
wondering if it has that system changed, or is there? I
Not at
was
this.
hoping. Okay.
Sorry, finish your question. I didn't mean to overstep. I'm sorry.
I was hoping that with the Starlink and stuff that there'd be no latency in the uplink and we could just directly, type the RS-232.
No, not at this
Okay.
time.
Okay.
It still has the request sheet, and then Aaron or I ends up manually doing it. We try to do it as immediate as possible as soon as we get them in. You could also, I wouldn't say schedule, but we do a little checklist for flights. And so we set times, this payload wants to send this command 5 minutes after launch. This payload wants to send this command at float, stuff like that. So you could, later on in the cycle, in the flop, you could actually document, we need to send this command, this. Again, that doesn't guarantee it gets sent with a zero latency, but we can try to schedule some stuff like that. Yeah, at this time, we don't allow direct team commanding.
Okay. I was wondering if it was possible to have an uplink, which is a receiver that might be in the 70 centimeter band or up in the maybe 900 megahertz or something like that.
Yes.
Oh yeah, we've had teams do that.
Yeah. If you want to fly some form of radio receiver on your payload and have a team on site commanding through the radio link, not through the serial link, yeah, that's not a problem. McMaster, there's a team that's been doing it for a couple of years now. McMaster University, Mukwan and them had something similar. So yeah, if you want to send a team to launch and do that, that is not a problem.
Okay, thank you. Yes, I have some more questions on video.
Okay.
And where the cameras are pointed, and if we can utilize that, or if we would like to have our own video. We can record it, but would like to ask you about how you're getting the video down.
So this year, we hooked up those 3 flight cameras to our network and telemetered it down through Starlink, and then piped it to YouTube, and teams could watch it. If you're on site, there's you could look at the flight computers to see the video, but we also pipe it to a YouTube feed. Normally that works really well. For some reason that is under investigation, the Starlink network was really choppy. And it didn't matter for our data link because of it's rsync and it's a bit redundant. There's redundancies built in, but for the video link, we would just drop. I mean, the latency would go crazy. We had periods of like 5 to 10% blockages, which makes no sense when you're up at 120,000 feet and there's nothing above you. It was just really choppy. So we're working on that. If there's not a valid or a real solution to that, and it was just CSBF flew their Starlink on a couple other payloads, so we're going to check with them and make sure that they didn't have any other issues. If that is still an issue, we will move the video cameras to the EVTM system, which is just a unidirectional downlink, and then it'll just be piped to YouTube. So it'll be visible at flight operations on flight computers and or on YouTube.
All right. Thank you.
Live streamed YouTube. Sorry, let me clarify. So there's there's a 15-20 second redundancy or latency in that depending on the YouTube feed, but yeah.
Okay.
Can I comment on that?
Sure.
Now, Larry, this is one from Gainan University. I'm not sure if you have met, but there's a company in UK called Tech. That's what I'm using to have a direct link from my payload to the ground station to deliver the video streams. So if you want to look at that, then check with a company called Tech, D-E-K-T, I can't spell exactly, DCTK or something like that. But they have several DAVT, the video transmitting devices, but they are some pricey. But they have a late development to hook up with a USB port and things like that. Mine is through a different one because I've been for a few years, but they have a latest product that they sell for video transmission. And they need to have, I think they have a fairly large range of RF, but all that probably will end up transmitting at 430 some megahertz band like I do because of whatever regulations in New Mexico, Arizona, ham bands, all that stuff. Just a full information.
Okay, can you guys hold off? There's a couple more questions and it's 11 and I want to make sure that the other people who have questions can hang on for a minute. Oliver, Garth, Aza, if I pronounce that name wrong, I am terribly sorry. Are you guys available to just hang on for a little bit longer?
Yeah, absolutely. Thank you.
Garth? Okay, thank you. All right. Now we could finish the video question up. I just wanted to make sure that they could hang on and anyone else who had questions. But yeah, Larry,
I would just like to
feed.
ask him to spell the name of that English company, as I didn't quite hear it.
How about we email Wuquan and we'll get it from him?
Just
okay,
is it Beck Tech with a B-E-K?
T as in David, E as in Edward, K as in King, T as in Tom, E Edward, and C as in Charlie.
Okay,
I just dropped the link in chat. They make a PCIe SDRs, so that's what he's talking about.
Okay, thank you.
Yeah,
I appreciate it.
Yeah.
Any more questions, Larry? Or you said you had a few. Good. All right, Oliver. Can't hear you, Oliver. Still can't hear you. You could type it in chat. I'll go to Garth and then we'll come back. But yeah, I can't hear you.
Hey, thank you, Doug. It's great to be here. I had just a couple of questions.
Yep.
Is it possible to put moving parts on HASP? So if we wanted to test like an attitude determination system, attitude control system, and put reaction wheels, is it
Yeah.
possible to have moving parts?
Absolutely.
And then so we have a footprint and a volume on the payloads that we have to design for. If our moving parts cause us to go outside of that envelope for a little bit, is that okay?
That would still require the
Yeah.
width waiver. You just need
Okay.
to document why you need to do that outside of the area.
Okay, for sure. And I have
And
a
depending on where that goes, that may not be approved because, like for example, if you look at that, the large payloads that Doug shows there, there is actual structure that you could you could move into, and we're not gonna, that's not gonna work. But if it was like, one of the small payloads out on the side, you would sweep out past that extent above the payload plate. That's something we would be willing to approve, probably. So
yeah, it would be the latter.
right.
So you're
But
looking at a
that's
small.
why we need a
Yeah.
documented waiver request so we can determine the impacts and approve or deny.
Yeah.
Okay, thank you. One more question is if we have a camera that's pointing straight up, I imagine that mostly what that camera would see if we're on the top level would be the balloon and not really the sky.
You'd get a pretty good view of the sky. The balloon's there. You will probably get it. You'll get it, some coverage. I don't know exactly what, but you would get a good chunk of the sky. You could also just adjust it slightly, right? So instead of having it straight up vertical, you could, canter it out a little bit. And if you want to be like on this payload, you can just have it aiming out a little bit that way, and you'll get more sky, less balloon.
So I just posted a recording from last year's launch ascent up to float. That was with a 360 camera, so you can pan that up and you can kind of get an idea of the field of view you would have. So that might be a little bit more helpful.
Thank you.
Oliver typed his in chat. When are students required to attend physically, and for how many days at a time? All right, so if you're talking about just your payload team and constructing your payload, et cetera, that is up to your team. You guys discuss how long you need to work in your lab and stuff like that. If you're talking about for flight operations and integration, officially, you do not need to go to either. Integration is highly recommended that teams go to. That is, it's a week long for students. It's Monday through Friday week. You'll be at CSBF, and the basic timeline for that is Monday and Tuesday, student teams show up and integrate on the HASP. Wednesday, the entire HASP vehicle gets loaded into a thermal vac chamber, and you do an all-day thermal vac cycle. You come out Wednesday afternoon. Thursday, teams could fix any issues they have and reintegrate on the HASP. And Friday, we do it all over again. So that's usually the best time for students to be around. It's over the summer, which is a lot easier. And that's where you get your most hands-on interface with HASP people, with the HASP team, and with HASP itself. Flight is around Labor Day. School starts up. It's hard to get students there for a long period of time. But typically with flight, once your team gets mounted on the HASP, you can't touch your payload. It's flight ready. Once it's determined it's flight ready, you're not really allowed to make any changes. You could attend the flight. It looks pretty awesome when it's launching, and you could do testing. You get to tool around New Mexico a bit. But flights don't occur on a set schedule due to weather, other features, stuff like that. So you can HASP could show up for 3 or 4 launch opportunities before it actually occurs. So launch is very much fluid. Integration is very structured.
But if you're say for example you're looking for like what the de minimis recommended, these people attend this, I would say you probably want at least 2 people at integration and at least Monday through Thursday. That assumes nothing breaks, you don't have any issues, but travel to integration is a fixed schedule, and usually student teams get more out of it and are more successful by having the personnel there. So
before I get to Aiza, Fanny, how many people do we recommend per team? It's up to you guys. We've had teams as small as 2 to 3 people. We've had teams as large as 25 to 30 people. It's 25 to 30 is probably way too cumbersome.
Yeah.
I would say somewhere in the 5 to 10 is the easiest managed. And this is over almost a whole year, or basically a whole year. So some people can come and go, and a lot of them aren't necessarily there the entire time. Seniors can graduate, et cetera, et cetera. You could add new peoples for stuff like that, but a good 5 to 10 is probably best, but that's up to you guys to decide how you spread it out. And anyone working on the project at any point in the year is considered a team member for our numbers. So that 30 could have been 10 working on it at one point, 10 working on it at another point, and 10 somewhere else. But go ahead, Aaron. I'm sorry.
And I was just going to say, like, there's a pretty large difference team to team on complexity of the design and the time commitment students have available, or the background skill level of students. So I don't think we can really give you a meaningful question answer to how big your team should be. It all depends, because there's a big difference between an undergrad who has 2 hours a week and a grad student who's working on this is part of their thesis project, right? So
Aiza, I hope I'm saying that right. Please tell me if I'm wrong.
Hi, can you hear me?
We can hear you.
Okay. I have 2 questions. My name's pronounced Isa. That was pretty spot on. But for the 2.2 section where we talk about our timeline and stuff, do we talk about our process of proposal too, or just how the future integration process would look like? For
I would basically start at, say, January. You could start at proposal time, but those are set. So you could just put the date, proposal submitted on this date. You could start team working, and January is kickoff. But some teams will start working ahead of time too. So.
And then my second question is, for the preliminary diagrams, do you have like any of the preferences besides having like technical dimensions? Like, would you prefer 2D, 3D, or any other things for, just any of the preferences?
Mechanical drawings, 2D drawings are usually easier to read in paper. 3D models are nice, but they're not particularly useful for looking at drawings. Like system diagrams, block diagrams are useful. If you are at the point where so Doug mentioned the appendices for additional drawings. Like that's where, like, hey, you have your full schematic drawings for X subsystem. That's sort of the place where you want. But really, yeah, it's showing that you are fitting inside the payload, and then a block diagram system level or subsystem level diagram showing functionality is really what we're looking for in the application.
Okay, thank you.
Yeah.
Colby.
Yeah. So based on the requirements, I think it said like we were going to be, or HASP itself was going to provide 26 to 30 volts, and then each payload would have access to, I think, like 0.5 amps. So I guess that would come up to be like 13 to 15 volt or watts in terms of power. So this our usage of HASP would be to apply it to a later mission through some other organization, and to get a realistic basis on what that would provide, we expect to need more power than that. But if that's the case, then we just fill out an extra application. There's just some like more paperwork we have to fill out to say, hey, you know, if we request more power than that, just say that this is what we would use, and then that would have to go through some, I guess some looking over to verify that would be okay.
So there are two classes of payloads, right? So the small payloads, as you said, are limited to 0.5 amp. The large payloads are 2.5 amps at nominal 28 volts. So if you needed a larger current limit, that's one of the reasons those exist. You could, if you needed a small physical seat and a large current limit, that is something you could request in a special request form, or as a waiver request, special request. So as far as how high that power limit could be, that's that's a very complicated question because it has to do with the power distribution system. But yes, up to 2.5 amps, like that's why one of the reasons the large payload class exists.
Okay. And I guess to go off of that, so because our, like physically, we would fit under most of the small payload parameters. But if we do request more power, would that be in the sense of we would still have a small payload seat, but would have the large payload power, or would we now be placed in like the large payload section?
It would sort of depend on the whole array of applications, and so it also like for example, if we get a lot of small payload seats and you don't need to be on a small payload seat, and you would, like you didn't need downlooking, for example, and you asked for a small payload seat with a large, we would probably write back and say like, okay, we can't provide that, but we can provide you with a large seat. Would you basically do a preliminary acceptance along the lines of you are accepted under these conditions sort of thing? And we really won't know the answer to that until we see what all of the so our goal is to accept the largest number of flyable seats missions as possible, but we can't assess whether or not what we would be able to provide until we see what the applications are.
Right. Yeah, that makes sense. And additionally, looking at the so our team is part of like two separated teams. One team focusing on HASP, an application through HASP, and then another one we're actually building a ground station for our university to use in future, potentially future CubeSat missions. And they had a question that they sent in that I can type in chat. Because they weren't able to attend. But some of the stuff I assume is either through the CFP payload constraints or either through the HASP student payload interface manual. But just in case any of that wasn't there, I was curious if maybe you could either guide us towards a resource that would have this, or that's something you can or can't tell us. I'm not sure.
Okay, so the way that that is, we have flight software and ground software that was was written here at LSU.
Right.
So the downlink telemetry is basically, it's a serial stream. That is the main housekeeping data. So that there's nothing too particularly fancy with that. It's like a plain ASCII string of the critical details. But it is also sent over a UDP unicast over the Starlink, if you know anything about that. And then the uplink commanding is one, it's part of the CSBF telemetry system. So again, there's a 1200 baud serial uplink, but with very specific formatting. And then the Starlink path it establishes a TCP connection from the ground station to the software, or the ground station to the flight computer. And if you really want to get into the weeds, there is it establishes like a secure, I can't remember what type of tunnel off the top of my head, between the gondola and the network router on the NASA mission network. So.
Okay. Do you know if there's any external resources that that would list any of that, or is that just based on you working on this, like you just know that stuff?
Yeah, I mean, like a lot of this is very like this isn't really like turnkey where I'd be like, oh yeah, just like this kind of thing.
Right.
Because it's pretty based on the specific existing NASA telemetry packages and their capabilities, and then other stuff that's just very general, like TCP/IP protocol, kind of stuff. So.
Okay. All right. Well, thank you for all that.
I think you heard some of the, like, if you're looking at building your own ground station using like your own like RF, either in a ham band or like the 900 megahertz low risk stuff. I think there are some teams that have some experience with that. And if they're still online and they wanted to drop an email in the chat, that might be more useful. And I don't know. There was also a lot of that as part of the solar 2024 National Solar Eclipse Project. So some of those resources are still online. So I don't know if that's exactly what you're looking for, but yeah, I would maybe look up some of the NEPB National Eclipse Balloon Project. So without knowing exactly your use case, yeah, I don't know if that's exactly so, but hopefully that's helpful.
No, it was. Yeah, thank you so much.
John.
So hello, Doug, and hello, Aaron. So it's just a statement, which is basically that UNF Space Science and Engineering is interested in the HASP 2026 flight. That's what Patel wanted me to tell.
Oh, okay. Okay. Dr. Patel had you call in. Okay. Gotcha. Understood. Yeah. He sent me an email. You guys, he had a different thing to do today. Sounds good. Thanks, John. Any other questions? Going once.
Wait,
Going
sorry, I have
twice.
one
Yeah.
question.
Go ahead.
If we have questions between now and the next meeting, how do we go about getting answers?
Email hasp@lsu.edu.
Can you put it in the chat, please, or the text?
Absolutely.
Thank you.
You email that, Aaron and I both get those emails, and so we'll be able to answer it as soon as we can. But remember, if you want to, if you're even considering, just submit an NOI. It's non-binding. You don't, just submit an NOI, letting us know that you're still interested and you're considering an application, and then go from there. But yeah, emails to hasp@lsu.edu will get to us as soon as we get it.
Right. And the other thing I'll add to that is sort of the point of this second teleconference is to hopefully everyone has started working on their proposals, and that way we can address specific questions that have come up as you've started writing. So.
Isa, did you have another question?
Yeah, it was a small question.
Yeah.
The HASP participant information website. I was just looking at the examples for the payload applications, and they just lead me straight to the general website. And I was wondering if
Oh, I'll fix it. And those examples are older too, but I'll check the link and make sure that you have access to some older applications.
okay, thank you.
I'll correct it today. I didn't realize they were dead links. Sorry. Okay, I'll fix that. Any other questions? All right. Well, after the meeting and after the video capture is complete and processed, I'll send out a link to everyone on the calendar invite that with a link to the video feed and the recording.
And you gonna post that on the front page of the website, Doug?
Yep. I'll put it on the website too. I'll put it, in the participant information. I'll add another field in there and post it there, and then post a link or a comment on it. All right. Well, thank y'all very much for coming. I hope to. Oh, wait, for the recorded meeting. Yes, Jennifer, I will send it out to the list of invite email accounts that I have for the calendar, so you'll get it. All right. Well, you guys have a good weekend, and hopefully I will see a bunch of you guys again soon.
Thank you.
Good luck. Bye.
Thank you.